We are now going to talk about UML diagrams and pseudocode. And for most people, this is where object-oriented programming really starts to click and make sense because we can put a picture to the code. So I always start out by saying, what do you think of if I show you this? Does this make any sense to you? Does it mean anything? And most people, particularly in this class, say, no, I don't know what that means, what it says, what it does, like, well, what is this? Okay, that's fine. We haven't spoken about UML diagrams, so I don't expect you to be able to recognize one. But that's what we're here for. What if I showed you this? Does this seem familiar? Now people say, yeah, didn't we do something like that a couple of videos or lectures ago? Well, yeah, we did, right? We made this class called Rectangle Client Constructor, which is pretty similar to rectangle. It had a length, a width, an area, a parameter. It had some constructors. I remember set length, get width, calculate parameter, calculate area, and toString. How about rectangle, get length, get width, set width. All of those things that we see are here in this UML diagram I'm pulling up right now. So how do we read a UML diagram? Oh, sorry, this is the UML diagram. How do we read a UML diagram? You kind of already are, right? This is the name of the class. In our case, it differs a little bit because we had two. These are the variables. They're written a little backwards. Instead of double length, it's length double. That's the structure of UML. Here's our constructors. Here's our methods, as you can see. These are our variables separated by the line of the box here. But let me take you into the PowerPoint to further explain this. So unified modeling language visually represents a system alongside its main actors, roles, actions, artifacts, or classes in order to better understand, alter, maintain, or document information about a system. So just like I showed you our rectangle class, if I said to you, imagine if I gave you this as an assignment and just said, hey, go do this. How would I even write that assignment? How would I instruct it? How would you know where to begin? How would you know what to do? What variables? What methods? What arguments? Everything. What to name things? How do I give... the code was quite large, right? Although it was repetitive, it was quite large. How do I give you an assignment to write this with clear instructions? Well, from now on, if you have an object-oriented programming assignment, it's probably going to be through a UML diagram. This is the UML for the rectangle, and this is a little table I made to explain what things mean. So this is the name of the class, and these are our variables in this box here. So the minus here means that it is a private variable, and we can see that right here, that they were indeed private variables. Like I said, we do write them a little backwards, so it's length double instead of double length in the UML diagram. The next box down is our methods. You can see these are our two constructors because they don't have a type. This takes arguments. Again, the variable and the type are written backwards. These are public constructors or methods, as you can see with the plus here, and that is again shown here. They are indeed public. As well as other methods that are all public, we can see here defined by the plus signs. You can see the arguments that each method takes if it does. You can also see the return type on the outside. So there's name type, and then the return type is after the method. So of course for the constructors there was no return type, but for all of the other methods, set length is void, get length is double. Let's check that. Set length was a void method, and get length was a double method. It doesn't matter if you write them in a particular order, because it matters in which the order of the methods were called, not written, so you can flip-flop them if you wish. But this is how you read a UML. Class name, variables, private or public, method names, arguments, return types. Pretty simple, right? So not too challenging, I hope. Now if I showed you this again, this temperature class, in the next video, I'm going to create this alongside of you. We're going to create a class for temperature and then run a demo to run the temperature itself. But I want you to, before going into that, try to create the code based on the UML yourself. So that's a little challenge. If you want to give that a go, please do. If not, jump into the next video for the solution.